हेलो एवरीवन। आज हम लोग का टॉपिक है मैक्सिमा एंड मिनिमा। सो लेट अस फर्स्ट डिफाइन maximum and minimum values of a function in its domain. So let us see what is maximum values. What is maximum values? Let fx be a real function defined on an interval a comma b, then fx is said to have the maximum value in close interval a comma b if there exists a point c in close interval a comma b such that f of x is less than equals to f of c for all x belongs to a comma b, close interval a comma b. Now let us see the graphical representation. Let us say we have a graph which looks like this. Let's say this is our curve. This is our y equals to f of x graph. And let us say this is your A point, this is your B point, and this is your f of c at c. Okay, the number f of c, this f of c is called the maximum value of fx. Okay, the maximum value of fx is f of c in the interval a comma b, and the point c is called the point of maximum value. This c is called point of maximum value. Okay, now let's see one example. Let us say fx is given by minus x minus 1 square plus 10. Okay, now you can see that x can take any value and y can take any value. So domain of f is any real number, that is from minus infinity to infinity. So you observe that minus of x minus 1 square is always less than equals to 0, right? This is positive quantity, but here is negative, so this quantity would be always negative for all x belongs to real number. Now minus x minus 1 square plus 10, sorry, plus 10, this is less than equals to 10, adding both 10 both sides for all x belongs to real number. So this is our fx function. So fx is less than equals to 10 for all x belongs to real number, right? If we put x equals to 1 in the function, then it will be 10. F of 1 is 10. So we can say f of 1, f of x, this 10 is f of 1. So this is less than equals to f of 1 for all x belongs to real number. So we can say f of 1 equals to 10 is the maximum value, and this is the graph of parabola. There minus sign is there, so the graph will look like something like this, where this point is 1, x is 1, y is f of 10. So this point is 1 comma 10, f of 1, that is 10. Okay, so we can see that at x equals to 1, the graph has the maximum value, which is 10. Now let us see the definition of minimum value. So definition will be same. Definition will be same up to this. Definition will be same up to this. There, in place of maximum, the word will be minimum value in a comma b if there exists a point c in a comma b such that only this function will change. It will be f of x is greater than equals to f of c for all x belongs to a comma b. Okay, so let's see the graphical representation. This would be something like this. Let us say this is our graph. Okay, let us say this is our graph. This is your a point, this is your b point, and let us say this is c point and the value is f of c. So in this graph we can see that fx, that is this graph, is always greater than or equals to f of c, is always greater than equals to this height, right? Let's see one example. Let us say we have a function f of x equals to x square plus 5. Domain of f is all real number, right? Minus infinity to infinity. See, x square is always greater than or equals to 0 for all x belongs to real number. So adding 5 on both the sides, x square plus 5 would be greater than equals to 5 for all x belongs to real number. Or if we put 0 here, f of 0, x equals to 0, then f of 0 would be 5. So we can say f of x, this is our f of x function, is greater than equals to f of 0. F of 0, right? So from this expression we can see that fx is greater than equals to f of 0. Okay, so that means the graph has the minimum value at x equals to 0. Okay, so let's see the graph of this. There is a parabola, right? There is a graph of parabola. This is the graph of this function. This point is 0, 5. This is your graph of fx equals to x square plus 5. So from this graph we can see that fx is always greater than equals to f of 0, because at f of 0 we got the value 5, right? This is 5. So that's how we can find out maximum and minimum values. Now let us see some question regarding maximum and minimum values. Let us say we have this question: find the maximum and minimum values, if any. F of x is equals to minus mod of x minus 1 plus 5 for all x belongs to real number. Let's see the solution. See, if x is a real number, then mod of x minus 1 is greater than equals to 0, right? For all x belongs to real number. Now here is minus sign is there because mod always give positive value, right? So minus of mod of x minus 1 will be less than equals to 0, because when we multiply minus in both the sides, greater than sign will be less than sign for all x belongs to real number. Now we have the addition of 5, so we can say minus mod of x minus 1 plus 5 is less than equals to 5 for all x belongs to real number. So this is our fx function, or f of x is less than equals to 5. Okay, so this is in the format f of x less than equals to f of c, right? So 5 is the maximum value because we have to find the maximum and minimum values. So value is 5. So 5 is the maximum value of f of x. Now let us see f of x is, if f of x is equals to 5, this implies mod of minus mod of x minus 1 plus 5, that is equals to 5. This implies mod of x minus 1 is equals to 0. 5 minus 5 is 0. So mod of x minus 1 is 0. This implies x equals to 1. X minus 1 is plus minus 0. So that doesn't mean. So x equals to plus 1. Okay. So ultimately we can say fx attains maximum value 5 at x equals to 1. And what will be the graph of this function? It will look something like this. So graph attains the maximum value at x equals to 1. And this is in the format y equals to mx plus c, right? So if you remove mod, you will have two equations, right? One is positive slope and one is negative slope. So this is the graph of fx equals to minus mod of x minus 1 plus 5. And if you notice, if you put minus 4 here, so it will be minus 5, and here is minus, so it will be plus 5. It is minus 5. The mod will absorb minus, and it will be minus 5 plus 5, that is 0. So at minus 4 comma 0, this line will pass. And if you put 6 here, so 6 minus 1 is plus 5, and here is minus, so minus 5 plus 5 is 0. So it is 6 comma 0. That's how the graph looks like. Now our next topic is local maxima and local minima. Local maxima and local minima. So we have just seen the maximum values and minimum values, okay? But there may be points in the domain of function where the function does not attain the greatest value or least value, but the values at these points are greater than or less than the values of the function at the neighboring points. Those points are called local minimum or local maximum. So let us see the definition of local maximum. Function f of x is said to attain a local maximum at x equals to a if there exists a neighborhood if there exists a neighborhood a minus delta a plus delta of a such that f of x is less than f of a for all x belongs to a minus delta to a plus delta to a plus delta x not equals to a. So you can say from here f of x minus f of a is less than 0 for all x belongs to a minus delta to a plus delta where x not equals to a, right? The value of the function at x equals to a, that is f of a, is called local minimum value of fx at x equals to a. The points at which function attains either the local maximum value or local minimum values are known as the extreme points or turning points, and both local maximum and local minimum values are called extreme values of fx. So a function attains an extreme value at x equals to a if f of a is either a local maximum value or a local minimum value, and at extreme points a, f of x minus f of a gives the same sign for all values of x in a related neighborhood of a. So let us understand by one graph. Let us say we have a graph this. This is our graph. So you can say, let us say this is our A point, this is our B point, this is our C point, this is D, and this is E. And this is y equals to f of x curve. So from this figure we can see that the x coordinate of points A, C, and E are the points of local maxima. This point, this A point, this C point, and this E point are the point of local maximum, and the values at these points, that is y coordinate, are called local maximum values of f of x. Now if you consider B and D, B point and D point, you can see that these two have local minimum values, local minima, and their y coordinate value is known as local minimum value. Okay, that's all the local maxima and local minima. So we can see that by local maxima, by this is your local maxima, this is your local maxima, this is your local maxima, and this is your local minima, this is your local minima. So by local maxima or local minima, values of a function at a point x equals to a, we mean the greatest or the least value in the neighborhood of point x equals to a. So if we say this is our x equals to a point, then in the neighborhood, that is from this to this, let us say this interval to this interval, this b point has the least value, so that's why it is local minima. And see, if we say this is our x equals to a point, this is our x equals to a point, then within the interval this and this, we can say this is our local minima. But this point and this point, within the whole graph, this b point has the lowest value, so we can say this is global minima. And here we have maximum values, local maxima at a, local maxima at c, and local maxima at e. So we can say that we have three maximum values, but within the whole graph, let us say from e to b, in this interval, c has the global maxima, and B has the global minima. Okay, so this is not actually maximum or minimum values. This A, C, these are local maximum and local minimum values in the domain of the function. In fact, the function may have any number of points of local maximum or local minimum, and even a local minimum value may be greater than a local maximum value. If we say this value d, this d height is greater than a height, so this is local maxima, this is local minima, but local minima value is higher than local maximum value, right? So we can say that if a is a point of local maximum of a function f, then the neighborhood of a, the graph of f, uh, let us say we have a graph which looks like this. Let us say we have the graph looks like this. Okay, so let us say this is our f of a height at x equals to a. Then we can see that fx is increasing in the left neighborhood, that is a minus delta, in this neighborhood, comma a. From a minus delta to a, let us say this is your a minus delta point. From a minus delta to a, the graph is increasing. The graph is increasing, right? And in the right neighborhood of x equals to a, let us say this point, at this point, this is a plus delta, the graph is decreasing. So if we draw a tangent here, if we draw a tangent here and here, okay, you can see in the left neighborhood f dash x is greater than 0 because slope is increasing, and in the right neighborhood the slope is decreasing. So here f dash x is less than 0, and at x equals to a, if we draw a tangent at this point, it will be parallel to x-axis, right? That means here f dash a is 0. Okay, so this is the overall conclusion. Now we can say f dash x is 0, greater than 0 for all, for for x belongs to a minus delta to a, and f dash x is less than 0 for x belongs to a comma a plus delta. Okay, so let's see our next graph. In this graph, let's just say this is our graph, y equals to f of x, and at x equals to a, the value is f of a, the height is f of a, and if we draw a tangent here at x equals to a, comma f of a, we'll we get a tangent parallel to x-axis. That means here f dash a should be 0, right? And in the left neighborhood, we can say this graph has the decreasing slope, that is f dash x is less than 0. And in the right neighborhood, we can say the slope is increasing. The graph is increasing, slope is increasing. So f dash x is greater than 0. Okay. So here we can see that in the left neighborhood f dash x is less than 0, and in the right neighborhood f dash x is greater than 0. So here we can see that f dash x is less than 0 for x belongs to a minus delta to a, and f dash x is greater than 0 for x belongs to a comma a plus delta. So based on this two graphical representation, we can say a necessary condition, we can say a necessary condition for f of a to be an extreme value of a function f of x is that f dash a should be 0, is that f dash a should be 0 in case it exists, right? Again, we have certainly seen that f dash x should be 0. Here also f dash x should be 0 if there is a maximum or minimum point. Okay. So this result states that if the derivative test, it must be 0 at the extreme points, but a function may however attain an extreme value at a point without being derivable trait, right? But see, if we say that f of x equals to mod of x, so what is the graph? The graph looks like this. This is your mod of x graph. This is y equals to minus x. This is y equals to x graph. And So in this we can see that this graph has attained the minimum value at the origin, right? At the origin here, at the origin, we have the minimum value, even though it is not derivable at x equals to 0, because we know mod of x has a sharp edge. So at sharp edge, we cannot find the derivative, right? This is your note number 1, or you can say point 1. Now, let us see another note. This condition is only a necessary condition for the point, right? F dash a 0. This is only a necessary condition for the point x equals to a to be an extreme point. Extremum, that is maximum or minimum, right? It is not sufficient. That is, f dash a 0 does not necessarily imply that at x equals to a is an extreme point. There are functions for which the derivative vanish at a point but do not have an extreme value trait, extreme value thereat. Okay. For example, let us say we have a graph fx equals to x cube. So if we see f of 0 is 0, but at x equals to 0, the function does not attain an extreme value. Let us see the graph of this. The graph is this. This is a graph of y equals to x cube. This is a graph of y equals to x cube. Okay. Now, here we see that at x equals to 0, the graph has not any maximum value, right? So, the function does not attain an extreme value. In fact, on the left of x equals to 0, on the left of x equals to 0, the curve is concave downward, and in the right, the curve is concave upward. That is, the concavity fx changes as x increases to 0. So such a point are called point of inflection, where concavity changes here, concave downward to concave upward, where concavity changes those points, that is here at x equals to 0. This is known as point of inflection. Point of inflection, where concavity changes. Here in our example, concavity changes from concave downward to concave upward. So if x equals to c is a point of inflection of a function f of x, then f double dash c equals to 0 and f double dash x change its sign as x increases through c. Okay. Now let's see our next note. Geometrically, the above condition means that the tangent to the curve y equals to fx, that is this condition, f dash a equals to 0. Okay. F dash x equals to 0. Geometrically, this condition means that the tangent to the curve y equals to fx at a point where the ordinate is maximum or minimum is parallel to x-axis. We have seen that, right? Where the ordinate is maximum or minimum, it is parallel to x-axis. So we have seen in the note 2 that for all x for which f dash x equals to 0, do not give us the extreme values. The values of x for which f dash x equals to 0 are called stationary points or turning points. Okay, so this f dash x equals to 0, those values of x for which f dash x equals to 0 are known as stationary points or turning points. Okay, stationary point or turning points, and the corresponding values of fx are called stationary or turning values. And the values of x for which f dash x equals to 0 or f dash x does not exist are known as critical points. Those are also known as critical points. Okay. Now, our next topic is first derivative test for local maxima and local minima. See, we have seen that. Let us see the theorem regarding this. Let f be a differentiable function defined on an interval I, and let a belongs to I. A lies within interval. Then x equals to a is a point of local maximum value of f if f dash a equals to 0 and f dash x changes sign from positive to negative as x increases row a. Okay, f dash x should change sign from positive to negative as x increases through a. This is your local maximum test, and for local minimum x equals to a is a point of local minimum value of f if f dash a equals to 0 and f dash x changes sign from negative to positive as x increases to a. Okay, here for local minimum f dash a 0 and f dash x changes sign from negative to positive. Here we have seen in the graphical representation, right? Here sign is changes from negative to positive. And for local maxima f dash a is 0 and the sign changes from positive to negative. Okay, remember this to graph. It will be very easy for you to remember the theorem also. Now let us see some question regarding this. So this should be our now question number 2. Find all the points of local maxima and minima of the function f of x is equals to x cube minus 6x square plus 9x minus 8. Let's see the solution of this. Let y is equal to f of x is equals to x cube minus 6x square plus 9x minus 8. So let's find the first derivative. So dy by dx is f dash x, that is 3x square minus 12x plus 9. Okay, taking 3 common, it will be x square minus 4x plus 3. So for critical points, we know f dash x should be 0, right? So this is f dash x or dy by dx, that means 3 times x square minus 4x plus 3 should be 0. Now apply the middle term, you will get x equals to 1 and x equals to 3. So now let us examine. We see that dy by dx, that is this, if we have middle term, it will be thrice x minus 1 into x minus 3. Okay, now for local maxima or local minima, okay, let us examine the change of sign. So we have 2 points, 1 and 3. In the rightmost part it would be positive, negative, positive. So we see that dy by dx changes sign from positive to negative as increases through 1, right? So we can say that x equals to 1 is a point of local maxima, positive to negative. And here we see that as we go through this will be from minus to positive as we go through 3. So x equals to 3 is a point of local minimum. Okay, that's how you have to solve this type of problem. Okay, now let us see another question. Find question number 3. Find the local maxima or local minima, if any, of the function f of x equals to sin x plus cos x, where x is between 0 to pi by 2, using first derivative test. Let's see the solution of this. Now let us say y equals to f of x equals to sin of x plus cos of x. So let's find the first derivative first. So dy by dx, that is f dash x, this is differentiation of sin x is cos x is minus sin x. So for critical points f dash x should be 0. That means cos x minus sin x is 0. That means tan x is 0. That means, tan x should be 1, because if we take sin x in the right hand side and divide by cos x, it will be 1. So tan x is 1. That means x is tan inverse 1, that is pi by 4. Now see, x lies between 0 to pi by 4. So pi by 2, that is, this point is valid. Now you have to check if this point is local maximum or local minimum. Okay, so let's check. In the left neighborhood of x equals to pi by 4, we have, as x less than pi by 4, cos x is greater than sin x. We know the graph of cos x and sin x is the graph of cos x, and this is the graph of sin x. At pi by 2, cos x value is 0, and pi by 2 sin x is maximum. So this is the graph of sin x. Okay, now see, from 0 to pi by 4, let us say this is pi by 2, and from 0 to pi by 4, cos x is maximum, greater than sin x, right? So when x is less than pi by 4, this is your pi by 2 point, and this is, let us say, pi by 4 point. So x less than pi by 4, cos x is higher than sin x. So we can say cos x minus sin x is greater than 0. This is our dy by dx, right? So dy by dx is greater than 0. And let's check in the right neighborhood. In the right neighborhood of x equals to pi by 4. So right neighborhood is x greater than pi by 4. That is, if x is greater than pi by 4, then sin x is greater than cos x. So we can say cos x is less than value of cos x is less than value of sin x. So this implies cos x minus sin x is less than 0. This implies dy by dx is less than 0. So we can see that the sign is changing from positive to negative, right? Greater than 0 to less than 0 at x equals to pi by 4 through x equals to pi by 4. So we can say that x equals to pi by 4 is a local maximum. Local maximum. Okay. At x equals to pi by 4, x equals to pi by 4 is a local maximum. Or we can say if x has local maximum value at x equals to pi by 4. Now let us see our higher order derivative test. This is our next topic, higher order derivative test. Now in the exam, we should apply this method, higher order derivative test, because it is quite easy to apply. So here what we have to do, that is, let's see the statement first. Let f be a differentiable function defined on an interval I, and let C be an interior point of I such that number 1, f dash C is f dash C or f double dash C or f triple dash C to f n minus 1 C is 0, and number 2, if nth derivative exists and is non-zero, then if n is even, that is second derivative, fourth derivative, sixth derivative, right? If n is even and if nc is less than 0, this implies x equals to c is a point of local maximum. Okay, if n is even and fnc greater than 0, this implies x equals to c is a point of local minimum. If n is odd, x equals to c is neither a point of local maximum nor a point of local minimum. Okay, now so it is actually quite easy. You have to first find the critical points by taking f dash c equals to 0, and you have to find out double derivative. If that double derivative, and you have to put the critical points in the double derivative. If it comes out to be less than 0, then it will have maximum values, and if it comes out to be greater than 0, then it will have minimum values. That's all you have to remember in the higher order derivative test. Now see, uh, point of inflection. Point of inflection. An arc of a curve y equals to f of x is called concave upward if at each point the arc lies above the tangent at the point. Okay, so let us first write the derivation definition first. An arc of a curve y equals to f of x is called concave upward if at each of its points the arc lies above the tangent at the point. Okay, so let's see the graph. If y equals to f of x is concave upward curve, then as x increases, f dash x either is of the same sign and increasing. Okay, let us say this graph. In this graph, we can see that if we draw a tangent at this point, we can see that tangent is of the same sign and increasing, or changes sign from negative to positive. Let us say if we have the graph something like this. In this, if we draw a tangent here, then it changes sign from negative to positive. Okay, from negative to positive. In either case, f dash x is increasing, and so in both of the cases, f double dash x is greater than 0. Okay, so thus for concave upward curve, f double dash x is greater than 0. Okay, and an arc of curve y equals to f of x is called concave downward if at each of its points the arc lies below the tangent. Okay, then you will call that curve as concave downward curve. Okay, so this is your concave upward curve. and let us say concave downward curve. Let's see two graphs. Let us say we have a graph this, and this is your tangent. Let us say we have another graph this, this is your graph. Let us say this is the tangent. So in this we can see that at each of its points, the arc, this is the arc lies below the tangent. Okay, so these are concave downward curve. If an arc of as x increases, f dash x is in this case, in both of these cases, as x increases, f dash x, that is this tangent, is either is of the same sign and decreasing, or changes sign from positive to negative. Here sign is changes from positive to negative. Okay, in either cases f dash x is decreasing, and so we can say f double dash x is less than 0. So for concave downward, f double dash x is less than 0, and for concave upward, f double dash x is greater than 0. If we see point of inflection, that is a point where curve is changing concavity, that is concave upward to concave downward, or concave downward to concave upward. So in the previous slides we have seen that, but still when drawing, let us say this is f of c, this is your y equals to f of x. Okay, so we can say a curve y equals to f of x has one of its points x equals to c. This is your x equals to c point. X equals to c as an inflection point if f double dash c is 0, because here tangent is parallel to x-axis, right? If double dash x is 0 or is not defined, or is not defined. And number 2, if double dash x changes sign as x increases, rho x equals to c. Okay, so the main condition is f double dash x should be 0. This is the main condition of point of inflection, and f triple dash c should not be 0. Okay, so let us see some question regarding maxima and minima. So let us say this is our question number 4. The question is, find the points of local maxima or local minima, if any. Find also the local maximum or local minimum values, okay, of the function f of x equals to sin x minus cos x, where x lies between 0 to 2 pi. So let's see the solution of this. Let us say our y equals to f of x is sin x minus cos x. Okay. Now first find out if single derivative. It would be cos x. Cos x is minus sin x, so plus sin x. So you know at points of local maxima and local minima, we must have f dash x should be 0, right? So cos x plus sin x should be 0. That means tan x should be minus 1. So you know tan x is minus 1 at x equals to either 3 pi by 4 or x equals to 7 pi by 4. We cannot exceed the value x between 0 to 2 pi, right? So at 3 pi by 4 and 7 pi by 4, and x has value minus 1. So these are the possible point of local maximum and local minimum. Okay, now find out double derivative f double dash x. So this would be minus sin x plus cos x. So let's find out the value at x equals to 3 pi by 4. F double dash x, f double dash 3 pi by 4. We have to put the value. So minus sin 3 pi by 4 plus cos 3 pi by 4. That is minus 1 by root 2 minus 1 by root 2. That is minus 2 by root 2, and it is less than 0. So you can say that at x equals to 3 pi by 4 is the local maxima. Local maximum. And what is the value? Local maximum value is जो पॉइंट में लोकल मैक्सिमा है वो ओरिजिनल फंक्शन में बैठा देना है, तभी तुमको वैल्यू मिलेगा. सो एफ ऑफ 3 pi by 4 is sin of 3 pi by 4 minus cos of 3 pi by 4. This is the original function. If you calculate, the value comes out to be 2, root 2. Now let's check at x equals to 7 pi by 4. So at x equals to 7 pi by 4, we have f double dash 7 pi by 4 is minus sine 7 pi by 4 plus cos of 7 pi by 4. This is minus 1 by root 2, that is plus 1 by root 2. This is 1 by root 2. So the value comes out to be 2 by root 2. It is greater than 0. We know how to find out this type of value. We have seen in our trigonometric series lectures. Okay. So you can see that it is greater than 0. That means at x equals to 7 pi by 4, we have local minimum value. Local minimum. And what is the value? Local minimum value is f of 7 pi by 4. That is, you have to put in the main function sine 7 pi by 4 minus cos 7 pi by 4. That is minus 1 by root 2 minus 1 by root 2. That is minus root 2 is the value. Local minimum value is minus 1 by root 2. That's how you have to check this type of question. Okay. Now let's see another question. This will be question number 5. Question number 5 is, at what point the slope of the curve y is equal to minus x square plus 3x square plus 9x minus 27 is maximum. Also find the maximum slope. Okay, so let's see the solution. Let us say m is the slope and y is given as minus, this should be x cube minus x cube minus x cube plus 3x square plus 9x minus 27. Okay, so slope is m at point x comma y. Let us see. So slope is dy by dx. So first derivative be minus 3x square plus 6x plus 9. Let us say let us find out the second derivative. So dm by dx be minus 6x plus 6. Okay, because we have to find out the slope when the slope will be maximum. So slope is this. Now for slope first derivative is dm by dx and slope second derivative is d2m by dx square. So it is minus 6. So we can see that we don't have to put the values. d2m by dx square is minus 6. So it has the maximum value. So for maximum values, we know for critical points, we have to equate it to 0, first derivative. So minus 6x plus 6 equals to 0. This is x is 1. So at x equals to 1, we have the maximum slope. Okay. Now, what is the slope? Slope is, you have to put in this equation. If we put 1 you will get is minus 3 plus 6 plus 9. Sorry, you have to put in the main equation. So slope is no, for slope you have to put in the value of m. So you will get it as 12, and we want to find out the value. So at x equals to 1, if you put it here, you will get y equals to minus 16. So at point 1 comma minus 16, the curve has maximum value and the slope is 12. Now let us see some problem regarding applied problems, because in the exam a lot of 5 marks question for Cbse and for ISC 6 marks question will definitely come from this section. So I will solve 2 questions and let us target for 500 likes. If we get 500 likes, we will definitely upload more type of problem sums. So let us see question number 6. Show that of all the rectangles inscribed in a given circle, the square has the maximum area. Okay, so let's see the solution, how to tackle this type of problem. Let's draw the graph geometry. Let's say this is our circle and this is our rectangle. Let us say this is the origin. This point is A, B, C, D. Let's say this is our x value, this is our y. So let ABCD be a rectangle inscribed in the given circle at center O and radius is A. Okay, its radius is A. Let AB equals to 2x and BC equals to 2y. So applying Pythagoras theorem, we will get y square should be equals to am square plus om square. Perpendicular square plus b square equals to hypotenuse square. So a square equals to, if this whole length is 2x, then it's the middle point, it will be x, and if whole length is y, then it's the middle point, it will be y. It will be x square plus y square. So y is root under of a square minus x square. Let A be the area of the rectangle ABCD. Then what is the area of the rectangle? This length into breadth, that is 2x into 2y, that is 4xy. This is 4x and y is root under of a square minus x square. Your main target is to form this equation in one variable. See, here we have substituted the value of y in with respect to x. Once you do this, it will be very easy. The challenge is to make this equation. Now let us find out dA by dx, which is 4 times. We have to apply u into v rule. So let us keep a square minus x square. Differentiation of x is 1. Let us keep x as it is, and differentiation of a square minus x square to the power half, that is n into x to the power n minus 1, that is half of x to the power a square minus x square to the power half minus 1, that is minus half. So it would be root under of a square minus x square. Remember, we have 1 by 2 is here, and from this we will get 2x. A square is d0, and from this we will get 2x. So 2 and 2 will cancel out. It will be minus, and we have x, so x square. So if you simplify, you will get 4 times a square minus 2x square by square root of a square minus x square. Now for critical points, you have to make dA by dx should be 0. This implies 4 times a square minus 2x square by root under of a square minus x square should be 0. That means a square minus 2x square should be 0. This implies x is a by root 2. Okay. Now for maximum or minimum, we have to check the second order derivative. So let's find out d2a by dx square. We have to derive this thing again. So if we want to apply multiplication rule, then we can apply in this manner. ddx of, let us make it in the form of multiplication. So a square minus 2x square into a square minus x square to the power minus half. Okay, it will be 4 times. You have to make u into b rule here. So differentiation of a square is 0, and this is minus 4x. Keeping this term as it is, a square minus x square to the power minus half, plus keeping this term as it is, again this will be n into x to the n minus 1, that is minus half into x to the power minus half minus 1. It will be 3 by 2. So minus half into x square minus x square to the power minus 3 by 2. Differentiation of minus x square is minus 2x, and a square is 0. So if you simplify this, you will get minus 4x by square root a square minus x square plus x into a square minus 2x square by a square minus x square to the power 3 by 2. Now if you put this value x equals to a by root 2 here, you will get d2a by dx square at x equals to a by root 2. You will get minus 16, which is less than 0. That means we have maximum values at x equals to a by root 2, right? So if x equals to a by root 2, so if you put x equals to a by root 2 here, it would be a square by 2, 2a square minus a square by 2, that is a square by 2, that is a by root 2. So we will get y equals to a by root 2, right? So we have seen that x is y equals to a by root 2. That means it's a square. So two sides are equal, that means it is a square. So area A is maximum when the rectangle is a square. Okay. Now let us see our next question. Question number 7. Question number 7. Tangent to the circle x square plus y square equals to a at any point on it in the first quadrant makes intercepts OA and OB on x and y axis respectively. O being the center of the circle, find the minimum value of OA plus OB. Let's see the solution. Let P A cos theta, comma A sin theta be an arbitrary point on the circle x square plus y square equals to a square. If P lies in the first quadrant, then 0 less than equals to theta less than equals to pi by 2. Let's see the diagram first. We have a circle x square plus y square equals to a square passing through origin. So this is our circle with radius a, and let us say we have the tangent this. This is our tangent. Okay, sorry for the bad diagram, but this is our tangent. Okay, and this point is P. We have assumed it as a cos theta, comma a sin theta. Okay, so P lies in the first quadrant where theta varies from 0 to pi by 2, right? So what will be the equation of tangent? The equation of tangent to x square plus y square equals to a square at P a cos theta, comma a sin theta is P. We know that the tangent to x square plus y square equals to a square at x1 y1 is x1 plus y1 equals to a square. This is the equation of tangent to this circle. So here equation of tangent would be x1, that is x cos theta, plus y1, that is y sin theta, equals to a. Okay. Now what we can do is this tangent cuts x and y axis. So if we want to see the intercept at x and y, put y is equal to 0. If we put y equals to 0, we will get x cos theta equals to a, then x would be a by cos theta, that is a sec theta, right? So let us mark the points. Let us say this is our O point, this is your A point, and this is your B point. So what would be, this would be A, not A square. Sorry, the page is hanging. Sorry about the interruption. This is point is A cos theta comma A sin theta. So this is A square. And if we take A cos theta x, that is x1, and y1, that is A sin theta into y, this is A square. So this would be x cos theta plus y sin theta. This should be A. Okay. Now for x intercept, we make y equals to 0. If we make y equals to 0 here, we get OA equals to A sec theta. And if you make, so this point is your A sec theta comma 0. And for y intercept, you make x equals to 0. This x 0. That means y by sin theta. Y equals to A by sin theta, that is A cosec theta. So OB would be A cosec theta. So this point is 0 comma A cosec theta, right? So let S equals to, because you have to find first quadrant makes intercept OA and OB on x and y axis, O being the center of the circle. Find the minimum value of OA plus OB. So you need S, let S equals to OA plus OB. So OA is A sec theta and OB is A cosec theta. Okay, so this would be A sec theta plus cosec theta. So let's find out first derivative, that is ds by d theta. It is a sec theta differentiation is sec theta cos theta. sec theta tan theta, sorry, sec theta tan theta minus cosec theta differentiation is minus cosec theta cot theta. So minus cosec theta cot theta. Let's again differentiate. You have to apply u into v rule here. So it would be if you keep sec theta outside, differentiation of tan theta is sec square theta. So it would be sec cube theta plus keeping sec theta outside, keeping tan theta outside. This sec theta is sec theta tan theta. So you will get sec theta tan square theta. And again you have to apply u into v rule. Okay. Cot theta is cos square theta minus cos square theta. So you will get plus cosec cube theta. And if you put cot theta, cosec theta is minus cosec theta cot theta. So it will be plus cosec theta cot square theta. So for maximum or minimum, we know we have to make ds by d theta equals to 0. That means this whole term equals to 0. Equals to 0. Okay. So sec theta tan theta equals to cosec theta cot theta. So you can see that sec theta is 1 by cos theta, cosec theta is 1 by sin theta. So if you cross multiply sin here, it will be tan theta, so it will be tan square theta, and cot theta is 1 by tan theta, so it will be tan cube theta. So tan cube theta equals to 1. This is tan theta equals to 1. This is theta equals to pi by 4. So this is a critical point. So let's check. Let's put the value theta pi by 4 at d2s by d theta square. At theta equals to pi by 4. If you put pi by 4 value here, you will get 6 root 2a, which is greater than 0. So we can see that s is minimum. S is minimum at theta equals to pi by 4, and the minimum value is put it in the original equation. This a sec theta plus tan theta. So sec pi by 4 plus tan pi by 4. You will get 2 root 2a. Okay. So I think ये जो लेक्चर है तुम लोगों को अच्छा लगा होगा, तो इसको लाइक करो, सब्सक्राइब करो और शेयर करो. इससे मोटिवेशन मिलता है कि हम लोग और भी मेहनत करें, तुम लोगों के लिए और भी वीडियो दे. और इस वीडियो के लिए हम लोग 500 लाइक्स का एम्स रखते हैं. उसके बाद हम लोग और भी 15 से 20 क्वेश्चन अपलोड करेंगे, ताकि इस चैप्टर का और भी जो क्रिटिकल क्वेश्चन जो बोर्ड्स में आता है और जो बहुत ही कॉन्सेप्चुअल है, हम लोग अपलोड करेंगे. थैंक यू एंड हैव ए गुड डे.